Hi, good morning, everybody. I am Professor Vilas Nikam from Department of Civil Engineering, Sangli Polytechnic, Nasik. Today we are going to see the unit number 2, Theodolite Surveying, under the subject Advanced Surveying. In this lecture, we are going to cover the different topics like types and use of theodolite, component parts of transit theodolite with their function, reading of verniers of transit theodolite, technical terms related to the theodolite like swinging, transiting, face left and face right. Next, fundamental axis of transit theodolite and their relation, temporary adjustment of transit theodolite. Now let's go for types of theodolite. So theodolite is basically classified depending on two criteria. First criteria, classification based on horizontal axis. Theodolite is classified as transit theodolite and non-transit theodolite. So transit theodolite means what? The theodolite of which telescope can be rotated in vertical plane about horizontal axis through 180 degree. That is called transit theodolite. Non-transit theodolite means the theodolite whose telescope will not be rotated in vertical plane about horizontal axis. That is called as a non-transit theodolite. Second criteria, classification based on measurement of angle. That means how we measure the angle using vernier, micrometer and in total station. Vernier theodolite means in this theodolite verniers are provided to measure horizontal angle and vertical angle. In case of micro-optic theodolite, micrometers are provided. By using that micrometer, we have to measure the angles. And total station, this is a modern instrument in which we get the readings in digitalized form. So these are the different types of theodolite depending on mode of measurement of angle. Next is, what are the different uses of theodolite? So first use is measurement of horizontal and vertical angle, locating points on a line, prolonging survey line. Prolonging survey lines means what? Whenever you want to extend a line in a straight alignment for a larger distance, in that case we use this theodolite. Next use is finding difference of level, setting out grades, ranging curve, and for tachometric survey. Now, if you see in this figure, we have shown this. This is a transit theodolite that we have to see in detail in the chapter. Now, these are the different component parts. If you are able to see, first component part that is indicated by a digit first. So this is nothing but a vertical circle. And second part, this is called as a altitude bubble that is very near to the vertical circle. And the use of vertical circle is to measure the vertical angle. Use of altitude bubble to level the instrument. Third is horizontal axis. If you are able to see, this is the horizontal axis about which telescope can be rotated. Fourth is vernier arm. So these are the vernier arms. Fifth is plate level. You can see here is also one level is provided that is called as a plate level, which is very near to the horizontal circle. Sixth is graduated arc. You can see here we can get a graduated arc, okay, on both sides, which is 180 degree apart from one another. Next is vertical circle. So this is called as a vertical circle. This is called as a vertical circle. Next, telescope. This is the telescope which is in line with vertical axis. Next is vertical circle clamping screw. If you are able to see, this is a clamp screw. What is the function of this clamp screw? To arrest the motion or to release the motion of telescope. That means if you want to release the telescope or you want to tight the telescope with fixed position, then we have to use this clamp screw. Next is standard. See here, this arm is called as standard. This arm is called as standard. Next is line of sight. So the line of sight which is exactly parallel to the axis of telescope. Next is upper plate clamping screw. Upper plate clamping screw. These screws are provided over here. Okay, you can see this 50 number. This is a upper clamping screw. Next, axis of plate level. Axis of plate level. So this is the level, and this is called as the axis of plate level. Next is upper plate. So here, this is the horizontal circle. In horizontal circle, one upper plate is provided and another is called as a lower plate. This 80 number is called as a lower plate. Next is clamping screw. So you can see this is the clamping screw. Next is try badge. So this is the try badge, okay, which is triangular in shape. Next is foot screw. You can see these are the foot screw which are used for leveling purpose. And this is trivet plate. This is a trivet plate in which screws are fixed. And below this we have provided tripod stand which may be made up of metallic element or which may be made up of a wood. So that tripod stand can be folded and can be packed and transported at site. And last is plumb bob. This plumb bob is used for sintering purpose. So in this way, these are the different component parts of theodolite. Okay, already we have seen all these component parts. Now let's go for how to take the reading on verniers of transit theodolite. If you are able to see, this is the theodolite. There are two circles. This is vertical circle and this is the horizontal circle. On horizontal circle, there are two verniers. Vernier A is provided here, and vernier B exactly 180 degree to this vernier B. That means on horizontal circle you will observe two vernier A and vernier B. And this horizontal circle which carries vernier C and vernier D. Vernier C and vernier D are exactly 180 degree apart. Now let me tell you, this horizontal circle measures from 0 degree to 360 degree. In horizontal circle there are two plates. One is called as inner plate and another is called as outer plate, or you may call lower plate and upper plate. So upper plate consists of two verniers, vernier A and vernier B, and lower plate carries main scale which measures from 0 to 360 degree. One thing you should clear, main scale always indicate a reading in degree and minute, and whereas vernier scale indicate reading in minute and second. Next, if you see vertical circle is graduated in 4 quadrant, and that quadrant readings are ranges from 0 degree to 90 degree. That means whenever vernier C shows 0 degree, vernier D also shows 0 degree. But as far as horizontal circle is concerned, when vernier A shows 0 degree, then vernier B will show 180 degree. Now let's go for a reading. See, this is a one of the pictorial view of scale. Here B letter is written. That means this is a vernier B, and by using this vernier we can measure horizontal angle. Now if you are able to see, this vernier shows reading from 0 minute to 20 minute, and this outer or lower plate or outer circle that shows a main scale reading which is ranges from 0 degree to 360 degree. And here if you are able to see, this main scale shows reading from degree and in minute, whereas this vernier scale shows reading in minute and second. And here in this figure you will see these are the different position of horizontal and vertical axis. Now here if you are able to how to read the vernier, so for that purpose what we have to do, we have to see this is the vernier scale and this outer plate is called as a main scale. Now we will see how to take the reading here. Now this is the outer circle reading and this is the inner scale, or that is called as a vernier scale. This 0 to 20 minutes are vernier scale and this 0 to 360 degree is a main scale. Now how to take the reading? First of all we have to see where the 0 of vernier is touches to main scale. Where 0 of main scale is touches to vernier scale. Here you can see this 0 is touches to main scale after 30 degree 40 minute. Okay, it is not touching to 31 degree. Here you can see this is 30 degree, 31 degree, 32 degree, 33 degree, 34 degree, 35 degree, 36, 37, 38, 39, 40. So in this way, this main scale measures degree, and again 1 degree is divided into 3 equal parts. So if you consider 1 degree, 1 degree means 60 minutes. If this 60 minutes is divided into a 3 equal parts, that means each small part shows 20 minutes. Each small part shows 20 minutes. Now in this figure, this 0 is touches to 30 degree, 20 minute and 40 minute. After 40 minutes, this 0 is touches. Okay. Now this 0 is ahead of this 40-minute line. See 30 degree and 40 minute ahead of this 40-minute line. Now by how much amount that is ahead of 30 degree 40 minute, that we have to show on vernier scale. Now what we have to observe on vernier scale for vernier reading, we have to observe that there are number of lines on vernier scale, and out of which line is exactly coincides with a line of main scale. Any line, you can take any line on vernier scale which is exactly coincides with a line of main scale. So that is called as a vernier scale reading. Now here you can see this is the main scale reading that shows 30 degree 40 minute where 0 is touches to main scale. Now this 0 is just far away from this 40 minute or ahead of this 40 minute. Then by how much amount it is ahead, that we have to see. For that purpose we have to check which line is exactly coinciding with main scale. So we have assumed, or you can see this line is exactly coinciding with main scale. Now for that purpose what you have to observe, we have to measure the count of this line. So this line value is about this is a 15 minute, this is 16 minute, 17 minute. Now 17 minute and this is 18 minute. Again 1 minute is divided into 3 equal parts. As 1 minute is divided into 3 equal parts, that means each equal part shows a 20 second. Hence this vernier is also called as a 20 second. Now here you can observe this line, the value of this line will be 15 minute, 16 minute, 17 minute, 17 minute, 20 second, 40 second. Hence we have added 17 minute, 40 second. Now we have to just add vertically. Okay, here this 30 plus 0 is equal to 30, 40 plus 17 is equal to 57, and 0 plus 40 is equal to 40. Here you can see there are two dark blocks. In main scale you will observe this is the second block, this is a minute block, and this is a degree block. Now in this block of main scale, 0 is dark. That means you can't measure the second reading on main scale, and you can't measure degree reading on vernier scale. But you can measure the minute reading on both main scale as well as vernier scale. So in this way we can read the verniers. Now there are different terms related to the theodolite. So first term is facelift observation. So what do you mean by facelift observation? Whenever vertical circle is on the left side of the observer while taking the reading, then that is called as a face left observation. But when vertical circle is on the right side of the observer, then that is called as a face right observation. Next, swing of telescope. So what do you mean by swing of telescope? Rotating the telescope clockwise or anti-clockwise in horizontal plane above horizontal axis. See, this is the vertical axis and we have to rotate telescope about this axis in horizontal plane. So that is called as a swinging. That is called as a swinging. Now next term is transiting. Transiting is just opposite of swinging. In swinging, we are rotating telescope in horizontal plane. In horizontal plane. But in transiting, we have to rotate telescope in vertical plane through 180 degree about horizontal axis. That is called as a transiting. Turning the telescope through 180 degree in vertical plane about horizontal axis. About horizontal axis. That is called as a transiting. Just we have to rotate telescope through 180 degree. That means, see, if you want to change the face of instrument, you have to repeat two procedure or you have to perform two operation. First is transiting and then swinging. Then you can change the face of instrument. Now next is telescope normal. Telescope normal means vertical bubble upside and face of vertical circle is on the left side of the observer. That is called as telescope normal. Now face left observation is also called as telescope normal position. And opposite to this telescope normal, there is telescope reversed. Whenever vertical circle downside, vertical bubble is on downside and face of the vertical circle is at right side of the observer, then that is called as a telescope reverse. Next is fundamental axis of transit theodolite and their relation. Now these are the list of fundamental axis. These are the list of fundamental axis. First is vertical axis, the axis about which telescope can be rotated in horizontal plane. See, horizontal plane means this is the axis of the telescope about which the telescope can be rotated in horizontal plane. That is called as a vertical axis. This is the vertical axis. Now, axis of plate level. It is a straight line tangential to the longitudinal curve of plate level 2 at its center. Next is line of collimation. So line of collimation is nothing but line of sight. It is an imaginary line joining the intersection of crosshairs and centers of the object glass and its continuation. That is called as a line of sight or line of collimation, or you may say the line which connects the eyepiece and object glass. That is called as a line of sight. Next is horizontal axis. The axis about which telescope can be rotated in vertical plane. Suppose this is a horizontal axis, and about which the telescope can be rotated in vertical plane. That is called as a horizontal axis, or that is also called as Stonian axis. Next, bubble line of altitude level or telescope. It is an imaginary line tangential to the vertical circle bubble at its center and its continuation. That is called as bubble line or altitude level. Next is, what are the different relationships between this axis of telescope? So, first relationship is axis of plate level must be perpendicular to the vertical axis. The line of collimation must be at right angle to the horizontal axis. Horizontal axis must be perpendicular to vertical axis. Axis of telescope level or altitude level must be parallel to the line of collimation. And vertical circle must be read 0 when line of sight is exactly horizontal. So these are the relationship that must be there. If such relationship are not there, then there will be the chances of error in the reading. So thank you very much for today's session.